everybody. Now we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is question number 6.13. Find the voltage across the capacitors in the circuit of figure under DC conditions. And it is given that under DC conditions we need to find the voltage across the capacitors. That is the question. So we have drawn the circuit so that it would be useful for us to do the calculations and all. So under DC conditions, in the sense, this particular portion, this capacitor will be acting as an open circuit, so that we can remove this part. Here also it acts as the open circuit. Under DC conditions, the circuit will be looking like this. So this is the equivalent circuit of the same circuit under DC conditions. So only one current is flowing. Let us take it as I1 current. So if you write the KVL for this, Kirchhoff's voltage law, it states that in a closed loop, the summation of, or the algebraic sum of, the voltages in a closed loop is equal to 0. That is Kirchhoff's voltage law. So here if you take the first loop or the only one loop, then we start from here. So the current will be flowing through this, then through this path, then here, and then it ends here, isn't it? So through the first path, if you take the polarities, the entering path is plus, then minus, here it is plus, minus, it is plus, minus, like that it comes. So that we can write the voltage equation as 40 into I1 plus 10 I1 plus 20 I1 plus 60 volts, that is equal to 0. So it is 70 I1 is equal to minus 60, or we can take that I1 is equal to minus 60 by 70. So it is minus 0.857 amps. This much current will be flowing through this path. Okay. Actually, this capacitor C1 is connected across this 40 ohm resistance. So the voltage across this 40 ohm resistance will be equal to the capacitor voltage VC1, which is here given as V1 voltage. In order to calculate this V40 ohm, what is the meaning of this? It is the voltage across this 40 ohm resistance. Already we know the current I1 is equal to minus 0.857 amps, isn't it? So what is this V40? V40 is equal to that resistance value 40 into that current I1, right? So that is equal to 40 into minus 0.857. So that is equal to, this is minus 34.28 volts. This is the voltage across this 40 volts resistor. But the more thing you have to consider here is, I have taken this polarity as plus and minus here, which is just opposite to that of this capacitor voltage C1, because it is considered as plus and minus here. Okay, so this V40, where this polarity is considered like this, that is equal to minus of this V1, like that we have to take. Okay, or this V1 is equal to minus of this V40, right? So this is equal to 34.28 volts. This much voltage will be appearing across the capacitor. So this is one answer for us. We need to calculate this V2, which is the voltage across this capacitor, right? So for this case already we have taken this. No current will be flowing through this 50 ohm resistance. So here this V2 is the voltage which is available across the C2 capacitor, which is to be determined now, right? We need to find out this. This voltage is nothing but the voltage which is available across these 2 points, because no current is actually flowing through this 50 ohm resistance. So here we can take this as V2. Now we need to calculate this V2. So if this is your V2 through which the current I1 is flowing, and we know that the I1 current is already taken as minus 0.857 amps, right? So what is the voltage across this 20 ohm resistance? That is equal to this I1 into that resistance value of 20 ohms. So this V20 ohm voltage across this 20 ohm resistance, that is equal to minus 0.857 multiplied by this 20. So this is equal to minus 17. This is equal to minus 17.14, this much volts. But here we have marked the polarity already as plus minus. So this V2 will be equal to V20 plus this 60 volts. Okay, that is the voltage, that is the voltage supplied by this voltage source. So this is equal to minus 17.14 plus 60. So this is equal to 42.86 volts. This is the answer, second answer. So we got the two answers. This V1 is equal to 34.28 volts and this V2 is equal to 42.86 volts. Okay, thank you. Hope you have understood. Okay, thank you. Hope you have understood.